Hey guys, welcome back. So today we're working on this 20,000 watt Generac standby generator. This one comes to us from a local subscriber, Ravi, who owns a business installing and maintaining these units. This one was pulled out of service after glitter was discovered in the oil. I'm told the engine still runs, but it's on its way out. So this is a parts machine, and actually some parts have already been stolen from it, like the control panel. So the plan was to do a teardown video and find out what went wrong with the engine and potentially fix it. But a couple weeks have gone by and the plan has changed. Let me show you why. And the plan changed because I now have two more 20,000 watt generators. These also came from Ravi. These machines both have problems. I'm told neither one makes power, but they both have good engines. So the easy thing here would be to pull the generator from the one in the garage, swap it onto likely the machine in the back since it's the exact same model. And in theory, we should be good to go. This has a good engine. The machine is complete, but there is one problem with the plan, and that's the condition of the frame. At one point there was a bad battery in here and it actually rotted a hole in the bottom of this frame. So I think instead I'm going to do the hard thing and just harvest this engine. We'll move it on over to the machine in the garage and make that one complete. So let me get you set up a little bit better and get going on this. I'm thinking before we get this thing pulled apart, I do want to take a closer look at the engine. Potentially we could rebuild this in a future video. I'm told it still runs, but it is producing glitter. So it is wounded and likely needs to be opened up and repaired. So what I'm going to do is actually install the missing control panel. I want to crank the engine. We'll check the compression on both cylinders. And if everything checks out, we'll try to start it as is, see how the engine runs, and of course validate that this generator does in fact make power. Actually, it looks like the control panel is not the only thing we're missing here. Just happened to look over and saw that we have some linkage right here. And this is for the throttle. So there should be a stepper motor to control the engine speed. And it looks like that's missing. So yeah, that is going to be a problem. Yeah, it's kind of hard to see, but there is an idle set screw right there. So theoretically, we can tie this throttle plate up against it and then adjust the speed, as needed by adjusting that screw. All right, so we can get these parts out. We don't need them for now. Yeah, oil nice and clean, right to the full mark, although it does look a little bit gray on that towel. So yeah, definitely not a good sign. Let's take a look in the airbox. Nice and clean. Definitely well maintained. So I think I'm actually going to steal one of the servos from the machines outside because the control panel, it's not going to let this engine run without the proper speed. Even if I lock that in, it's going to only give me a few seconds to try to dial the right speed in. So yeah, let's harvest a part and get it where it belongs. And the last step here is just to get the ball connected. Definitely a little harder than I thought this was going to be. The issue was the second bolt, which is kind of under here. You can't get a wrench on it because all this is in the way. So the only option really was to take this apart before you could remove the bracket. But we are connected now. So that should be good to go. All right, let's get the control panel hooked up. It's pretty hard to get wrong. The connectors are unique. So you can only hook it up the right way. And it looks like we have a broken terminal here, so we definitely have to get that replaced when we rebuild this. So we're not going to be able to tighten it down, but it might be good enough to test with. All right, let's see if the system board is any good. Looks like it's powering up. And it's asking us to set the time, which we don't need to worry about for now. What I'm most interested in is, will the engine crank? Or is the engine locked up? So there is no fuel connected right now. So let's hit the manual button, see if the engine turns over. Okay, we have signs of life. That is a very clean plug that came out of there, so that's a good sign. So we get the compression tester on here, see where this cylinder comes in at. All right, let's see where the compression comes in at. It should be around 180 PSI, I would think. That is pretty high. I would say about 210, maybe 215 PSI. So this is a high compression engine, and they can get away with that because it runs on propane. Propane has probably the equivalent of about 110 octane. And let's check the back cylinder. And that plug too was virtually spotless. So let's crank the engine again. And we want to see a similar number here. Yeah, about 210 psi. So the engine has good compression. It should definitely run. So I'm going to get the plugs back in. I think next we need to hook up the propane. Then we'll try to start it. All right, let's check for leaks real quick. I think we're good on this end. Yeah, it looks like we do have a little leak right there. And I'm not surprised. I actually ordered another fitting. It's not here yet, but these two don't go together very well. You know, I only got about 2.5 turns before things got tight, which didn't seem right. So yeah, that's the result. A tiny little leak, which shouldn't be left that way. So we will swap that out later. But for now, we can do a quick test, and when the better fitting gets here, we'll swap that part out. All right, let's give this a try. We've got a light and the kilowatt plugged into the convenience outlet here. So assuming the engine starts, we should get power. So let's try it real quick. Contact. And it's hopefully just purging the air out of the system. Looks like we are set up to run in propane, which is good. Let's try it again. And we get nothing. So potentially we don't have spark. Okay, this pallet, probably not the best one, not very stable, but the engine did start, although it really struggled once running, but it did finally get up to speed. We weren't making power. The GFCI was actually tripped, so I got that reset, and it looks like everything's good. 122 volts, about 60 hertz. So I'm going to try to restart it. Let's see if it starts any easier. So on the surface, this does seem like a good machine. You know, we have excellent compression, the engine sounds good, and we're making power. So everything's working that should be working. And if it wasn't for the glitter problem, then I would say this thing is good to go. But of course, we do have a problem with the engine, and likely it needs to be gone through and rebuilt. That is something likely we'll do in the future. But for today, you know, I say we swap this engine out, make this machine 100%, and then we'll get it outside and put it to the test. But before we do the engine swap, let's just take a quick sample of oil. You know, I don't know if this was just changed before it was taken out of service, so I'm not sure if we're going to see much. And yeah, it's actually kind of hard to tell. But I can see some rings forming, you know, so that is metal in the oil. And we could probably pull the oil filter as well, but yeah, you can see it's getting worse. So yeah, the engine's definitely wounded, but I've seen a lot worse. But regardless, we have two good engines outside, and I think it would be best to swap it out for one that's not producing any metal. Yeah, it's hard to see, but way down there at the bottom, we have one more bolt. So once that's removed, the end panel should be free. This looks pretty crusty. I'm not sure we need to get them both off, but we have to get this one off for sure. And if we get both off, it'll just make things quite a bit easier. Oh. Well, that was easy. That one was pretty much already loose. Check this one. Yeah. So despite their appearance, they still seem to work just fine. So we need to get the divider out before we can get the generator off the machine, but the fan for the rotor is holding us up. So we're going to have to pull the rotor bolt next and use a puller to pull the fan off the tapered shaft. So I'm guessing this is metric, and an M6 1.25 seems to be the one. So I'm actually going to put the rotor bolt back in, and I'm going to push against that. You don't want to screw it in all the way. You want to give about a 1/2 inch so the fan can actually get pulled off the shaft. And these fans do like to break. So there's a chance, a pretty good chance actually, that we might break this pulling it off, being that there's a lot of plastic on it, but hopefully we don't cause any damage here. All right, we got the fan off in one piece, and we can now get this panel off. Now, the crazy thing is the brushes are right there. So if you need to change the brushes out, pretty much everything I've done so far you're going to have to do, including removing this baffle right here. So yeah, thankfully they don't need to be changed that often, but definitely a hassle if they need to be swapped out. So similar to what we do on portable generators, we now need to free up the stator side and support it with a 2x4 on the engine side. So that way the stator will be hovering. It'll make the removal a lot easier. So I'm going to remove these mounts. We also need to get the brushes disconnected. Then we can start the process of removing both the rotor and the stator. think we're going to need a puller to get that one off. So we can't put the puller down there because that's where the brushes go. That's a weak point. So a 2-jaw puller would work best. The one I have for portables is too small. And yeah, the other ones I have, they're all 3-jaw. But that one's too small. This one's the right size, but I'm a little worried about it because they hang down so far. I'm not sure if we're going to catch the slip rings on the way out. Hopefully not. Oh, it's coming right out. Don't even need a puller. Dead blow hammer would have done that. So usually the next move here is to remove the stator and then the rotor. Because the fan is on the outside and that's removed, we can actually remove the rotor first, which I think will be better, although I say that. And this whole thing is supported by that piece of wood and the rotor. So if I take the rotor free, then there's really nothing holding the stator on either to the engine. So we actually need to prop the engine up better without using a piece of wood under the stator. So actually, before we pull that off, we do need to disconnect the wires from the stator. So I've removed the control panel again just to get access to what we need. We have the bundle of wires right here coming from the stator. We have 2 wires here. These are the live wires for leg 1 and leg 2 going into the breaker. And we have 2 neutral wires right there. So those 4 have to be disconnected. Also going into the control panel was this bundle here. 2 of the wires feed power to the brushes, and the other 2, I believe, are the sense windings. So those are already disconnected and ready to come out. We just need to disconnect the other 4 and pull the bundle through. And then we can move on to getting the rotor and the stator off. All right, now we have the fun part. We need to get the rotor and the stator off. So, I tried supporting it with a piece of wood right here, and I used the forklift to lower it down, and it just couldn't support the weight. So what we have to do instead is support the stator, remove the rotor, and then at that point the stator can come right out, but it won't come out before we're ready because this piece of wood should hold it in place until we're ready to pull it out. So to get the rotor off the tapered shaft, we actually have to sacrifice the rotor bolt. We need to cut about 1/2 inch off, slot it for a flathead screwdriver. We'll then thread it in and use an M12 1.75 bolt to push the rotor off the tapered shaft. Good enough. So I did end up having to cut this a little bit shorter than you just saw. Probably about 3/4 of an inch to maybe an inch. The issue is the first maybe 1/4 inch of this shaft, the threads really aren't well developed. So when I put in that M12 1.75, I only got about 1 turn of good threads. And you want to have at least, I would say, 4 or 5 turns before trying to push it off, because you might end up damaging the threads and then you're not going to be able to get the rotor off. Okay, we're all the way in. Well, I'd like to say the hard part's done, but I'm not so sure of that. You know, we still have the engine to pull out, not to mention the other machine outside we have to take apart to pull the swap off. So to get the engine out, we're going to have to disconnect both the fuel lines running to the mixer, the wires for the auto choke. We also have some wires down here for the pressure sensor, temperature sensor. I think that's the kill wire. And we also have a bunch of wires here on the other side for the starter, as well as the ground wire. So once all that stuff is removed, we can pull the bolts for the engine mounts and muscle this out of the frame. So I can't imagine it matters which side these wires go on, but for future reference, the blue connector with the black wire is on the left and the blue wire is on the right. And it looks like it's the same for the temperature probe, blue wire on the right and black wire on the left. I pulled the servo off thinking it would give us better access to the fuel lines where they go into the mixer, and it does, but there are clamps on there, which I was not anticipating. So I don't think I can get those clamps off. We don't have enough space. So instead, I think we'll pull these clamps, pull the lines directly from the regulator, and then once the engine's out, we can reclaim the lines. We got to pull this piece of plastic. There's just no way to get the tool on there. Huh. And this bolt's already loose. Huh. So's that one. So we're going to have to pull this anyway. Most likely, to hold the crank still, we're going to have to get a wrench on the flywheel. Although I say that, and there is a protective screen, so I guess the question is there a cutout for a wrench? And the answer would be no. But it looks like we do have access to the bolts to pull the screen if we need to. And we are down to a bare frame. Really not much left. So I'm going to spend a second just clean this up, and then I'm going to get this shell outside or bring the donor machine in and repeat the process. So we've got the donor inside the garage, and You know, as far as recording this one, I'm probably not going to record a whole lot. This is exactly the same model that we just tore down, so there's not a whole lot to see here. But I'm going to turn the camera back on for two things. I want to do a compression check, make sure both cylinders are good, and I also want to test the rotor and the stator. And I want to find out where the failure is and if either component is still good. All right, we got a big update here. It's only been a couple minutes, haven't taken anything apart, but I think I already found the cause of the failure on this generator. You know, I was looking things over and I noticed that the exhaust for the stator, it wasn't connected to the boot, but the connection, it is still there. It's just out of position. It actually looks like the whole stator rotated counterclockwise because this bolt right here should actually be more on the top. And if you look over here, you see more of the same. These wires should be exiting on the bottom, and instead, when this thing rotated, they got pulled and stretched, and they're actually pinched now between the stator and the stator bolt. And you can see the wires, they are deformed. The one over here actually looks like it shorted out and got cooked. So, yeah, not exactly the failure I was expecting to see here. I kind of thought we'd have an insulation failure with the stator, but in this case, it looks like the issue was that the stator bolts were not torqued properly. And when the rotor spins, that is an electromagnet, and when you start pulling power out of the stator, that actually builds the opposite magnetic field. So if it's not tight, then this will want to spin. And if it spins, that's pretty much it for the stator. So before I take this apart any further, I'm going to check the compression, starting here with the cylinder in the front. You want to see about 200 psi. Yeah, and this one's a little bit over 210 psi, so the front cylinder seems to be good. Let's check the back. All right, same test for the back cylinder. We want to see about the same compression. Yeah, maybe a little bit more. I'd say 215 psi. So I jumped ahead a bit. We got the exhaust off and we're about to get to the fun part. But before I pull it off, I'm kind of curious to see where these are at. A Generac only calls for 72 inch-pounds on these bolts, and that's not a lot. The portable generators I work on usually call for 80 to 120 inch-pounds, and I would think this being a larger machine with larger stator bolts that the torque spec would actually be higher and not lower. Anyway, I've got this set to 72 inch-pounds. Let's see if we get any motion here. A little bit. Ooh, that one's really loose. That one was fine. This bottom one's very loose. Yeah, so these two were under-torqued, I would say, and that's why this thing spun. So let's get the bolts out, let's get the generator off, get the engine out, and then we can start putting the machine back together. Remember, it's going to pop out toward you. Yeah, now that the stator's out, you can kind of see the extent of the damage, especially to this wire right here. This one, there's almost nothing left. That for sure would have been shorting out to that rotor bolt, or actually the stator bolt that was right there. The other wires don't look that bad. I mean, this one for sure got stretched, and this one I thought was burnt, but it actually just looks to be like some sort of glue or coating on it. So the rest of the wires actually look pretty good. And if you actually look at the stator itself, you know, it appears to be in excellent condition. I don't think the stator actually melted down. I think it's just a wiring issue. So potentially it's still good, and this could be repaired. So let's test it, see where it's at. So I'm just cleaning up the slip rings here. You know, I don't know the exact specs on this rotor. You know, I do have a specification sheet from Generac, but it's kind of a generic sheet. And there's a big note that says specifications are subject to change. So yeah, it may not help us too much, but according to the spec I'm looking at, it says this rotor should be between 9.5 and 11 ohms. And this one actually comes in at 4.78. So a little lower than expected. We'll check it for a ground fault. No fault to ground. So the rotor, little suspect based on the specs, but otherwise I don't see an issue with it. So let's check the stator. All right, so let's check this leg. Wire 11 and 22. According to the spec, it should be between 0.04 and 0.05 ohms. And yeah, we're at 0.041, so that appears to be good. Let's check the other leg. We should have the same reading, more or less. Yeah, 0.045, so both are within spec. Let's just check each winding to the other. There should be nothing. And there is no connection, so that is good. Let's check for a ground fault. No ground fault on that leg. Let's check the other. Okay, leg 1, leg 2 seem to be good. So let's check the sense winding in the DPE. And for the sense winding, I'm going to use this multimeter. It's not as precise, but I can't get the probes of the other one in here. The sense winding should be 0.15 to 0.18. And I'm not sure which two wires they are, so it might take a second to find it. Not those. Let's try the other side. 0.9. So we're a little bit low. You know, so potentially we do have an issue there. Let's check it to ground. No fault to ground. We'll check it to the other legs. And no fault to the other legs. So yeah, maybe a little suspect. But again, no red flag. And then we just have the sense winding. So this pin should connect over to one of the legs, which it does. And it should not connect to the other leg, which it does not. So if we move this over and probe the other leg again, yeah, we have a connection and should not to the other. So yeah, I would say there's a good chance that the stator and rotor are good. You know, obviously we have to repair the wiring, but I think if that is repaired, then this could be used potentially on the other machine out there. But for now, I'm going to move it out of the way. Let's finish up the machine we're working on now. So we're now fully disassembled. There is nothing left but a shell of a generator. And the whole reason we did it was because of this problem right here. You know, we just have some bad rot going on due to battery acid leaking out at some point. So yeah, this carcass I am going to get out. We'll get the other one in and start to put this back together. All right, so we did the swap. We have the good frame in the garage. So next we have to put the good engine on the good frame, which is this one right here. So before we get it installed, I actually want to check the valves. You know, that is something that is commonly overlooked. And although the compression tests well, you know, it doesn't mean that the clearance is correct. So let's double check that real quick before getting this engine installed. So I'm going to go ahead and get this protective screen off. You know, we need access to the flywheel nut to rotate the engine to top dead center. And we're also going to need to get a wrench on there to hold the crankshaft still when we torque down on that rotor bolt. So just 4 bolts. Bottom one looks a little crusty. All right, we'll come back to that one. All right, we're loose, but half the gasket's stuck on the top, the other half on the bottom. Try to save it if we can, because I don't have another. No. And it broke, of course. So, yeah, that's a problem. You know, potentially we could steal the cover from the parts engine. Anyway, let's rotate the engine over. Let's get to top dead center, and then we'll check the clearance. Yeah, we're at top dead center now of the compression stroke. Generac calls for 0.003 plus or minus 1,000th. And a 3 fits in there on the intake and the exhaust. Let's try the 4. Pretty good drag actually on the 4. And same thing on the exhaust. So this side seems to be good. You know, as far as the gasket goes, it actually only ripped right there. So I'm thinking a dab of RTV. Maybe it'll seal. So I'm just making sure that is all degreased. Our TV will not stick to oil or form a good seal. So I'm going to order a new gasket. You know, I did pull the cover off the parts engine, and of course the gasket stayed on the head, so that isn't going to help us in this situation. And technically you could just pull the gasket off and use RTV to make the seal, but yeah, I prefer not using RTV. It's just harder to clean up the mess. All right, let's check the other side. Same story over here. The left side staying on the head, the right side staying on the cover, although just released. So that gasket came off fine. So I'm going to rotate the engine clockwise and keep an eye on the piston and the valves. You want to be on the right stroke. So what we want to see is that the intake opens. The piston should be going down. And when the intake closes, now the piston's on its way to the top. And I think we're there. Let me just double check. And we went actually a little bit past it, so I'm backing it up. All right, right there, we're at top dead center. Yeah, we definitely have clearance. Let's check 3 thousandths. That is the middle of the spec. Both fit fine. How about 4? 4 does have some drag, although not a lot. So these valves are opened a little bit more. And technically 4 is the high side of the spec, but to be honest, you know, I'd rather be on the high side or a little bit above than the low side. But let's try the 5 thousandths. And actually a 5 doesn't fit. Or I should say it fits, but it's super tight. So yeah, actually these valves are in spec. They're both at about 4 thousandths. So no adjustments needed. Forwards. More. All right, I see the problem. Stop. There we go. All right, forwards. More. All right. Down a bit. Stop. Up a little. A little more. Stop. All right, down a bit, tiny bit. A little more. There we go. Let me check the other side. It's probably not in. There it is. All right, the other side's in. I think you can slowly put it down. Beautiful. And we'll get the auto choke plugged in next. Yeah, it's going to be kind of hard to show you here, but we need to connect 3 wires to this lug on the starter solenoid. We have 1 wire for battery charging, 1 wire to power the control panel, and of course the main power coming from the battery, which will crank the engine. And this is the trigger wire. This is what triggers the engine to crank. Don't want to forget that. And these wires eventually going to get zip tied right to the solenoid. But I'm going to come back and do the zip ties later once we get everything a little bit better situated. And we're just about done here with the wiring harness for the engine. So the last thing we need to do is connect the ground. There's one here from the frame that connects over to the engine, and the other goes up to the ground bus bar up in the control panel. And with that, the engine is more or less done. So next, we need to get the generator installed. And usually it's not a hard task, but this one is because it is very heavy. And what I usually do on smaller machines is prop a piece of wood right here to support the engine. You know, put the rotor on first and then slide the stator over. And that works on smaller machines, but this one, it's not going to work because the rotor is so heavy. Even with proper support, the engine mounts stretch and the rotor is allowed to tip down. And it goes so far down that it's only a few inches off the base. And like that, we can't actually install the stator. So we have 2 other options. The first one, which a lot of people do is use a piece of wood, like a 2x4, just run it across, set the stator down, and get it into position, and then just slide the rotor down the center until it's on the tapered shaft. And that, we might have to do that, but I don't like that idea, only because you have to just push it down the length of the stator, and it's making quite a bit of contact along the way. So it's not ideal, but it would probably be okay. But in this case, we're not in the field, and I have a manual forklift. So what I'm thinking I might try is to actually get the rotor in the stator right now before trying to install it. That way we can do it with minimal dragging. We'll position it so that the rotor is kind of favoring the engine side by a couple inches. We'll lift the whole thing up to the forklift, get it in place, bolt it down, and hopefully that's it. But if that doesn't work, we'll go to plan B and use the 2x4. But before we do any of that, let's finish cleaning these slip rings. I only cleaned maybe about a quarter of it, and there's really no easier time than right now to get at least the heavy buildup off. All right, so we get the generator reinstalled. Nothing's been torqued down yet. I got the engine mount in as well. Again, these have to be snugged up. At this point, we can't torque the rotor down until we get the divider and the fan reinstalled, but we can torque the stator bolts down. So let's do that now. So I think it's safe just to snug up all these mounting bolts. So we'll just snug up the mounting bolts and get the brushes reinstalled. Now, these still have life left in them, but given how hard it is to access, I think we should just replace them while we're here. So I got a wrench on the flywheel nut holding the crankshaft still, and like that, we can torque that rotor bolt to 30 foot-pounds. And before moving on, probably the most important thing to do is now rotate the rotor now that everything's torqued down. You want to make sure there's no binding, that you don't hear the rotor scraping the stator. And I did remove the spark plugs as well, just to make this a good test. Yeah, everything spins without issue. Yeah, we're getting pretty close. You know, pretty much everything from here over is complete. You know, I've got both plugs back in, the filter, both the boots, and we have the wires secured as well. And of course, everything else is tightened up. So really the next big thing here is just to tackle the wiring, the propane leak, and actually before I do any of that, I'm going to get this back on over the flywheel fan. I'm not going to record that because it's going to be pretty tight just to get me in there. But we do need to get that back on, and then we can finish up the wiring and try it out. So I think I'm going to redo these wires. They're not in great shape. You know, these are just held in place with a screw, kind of pressing it in place. And I think if we cut this off, get some clean wire, put a ferrule on it, you know, we'll end up with a much better connection. So these are the neutrals right here. Let's start with those. And for the last wire, 44, it gets a little sketchy because this is the one that they used a ferrule to combine two wires. And unfortunately, there's no bus bar for this. But basically, we're jumping over from one circuit breaker to another. And that other breaker is the output, or feeds the output to the convenience outlet. And I almost forgot to check what this is set up for. There is a lever under here, or actually more like a slide, where you can select between propane and natural gas. And that is it right there. So toward you, that is actually natural gas. So we need to slide that toward the outside. That'll switch it to propane and pull from the proper line. And that's it. So we're now metered for propane. So we'll get the cover back on. I think we'll fix that propane leak. Throw our battery in. And hopefully this still runs and makes power. It did before I took it apart. Yeah, propane's on. And no more leaks. So it's the moment of truth. Everything's connected that needs to be. The propane is turned on. We've got the light and the kilowatt plugged in. This engine tested very well, but we haven't heard it run yet. So that is still a bit of an unknown. And of course, we had the generator completely off the machine. So hopefully this engine starts, it sounds good, and we're still making power. So let's hit the switch and see what we get. I am very glad that things just went well. You know, this engine was kind of unproven and a bit of a risk. You know, it was a ton of work to get to this point, but I think it paid off because the engine started pretty much without much effort, even though there was air in the lines. And once that air was purged, the engine got up to speed and ran quite normal. And of course, the generator came on. So we were making 121 volts, exactly 60 hertz. So everything is looking pretty good. So besides getting the cover back on, both the top and the front, we actually do need to wire up some outputs for the load bank. So let's do that now, and then we'll finish it up. All right, so I'm going to feed in here some 6-gauge wire and make the final electrical connections. Now, technically, this wire is only safe up to 12,000 watts continuous. And of course, this machine makes 20,000. But one observation too is that the main wires coming from the stator, they're only 8 gauge. And what I'm attaching here is a 6-foot extension, so we can probably go over 12,000 during testing, at least for a short run. And for the 2 live wires, they connect into this circuit breaker down here. There's 2 terminals for it. Now, the interesting thing, though, is that to actually tighten it up, there is a hole through the outlet panel right here where you can spin that screw to snug it up. So it doesn't matter which one goes where. These are the 2 legs. So we'll just put the black one on the bottom. And the red one on the top. I think I put this on a little bit prematurely. You can't actually get the bolts in on that hinge with this cover installed. Well, it cleaned up pretty well, almost like new. So hopefully it runs under load as good as it looks. So let's get it outside and find out. I think we're pretty much ready to go here. I've got everything connected that needs to be, and I just made the final connection here in the control panel, which is to bond the neutral to ground using this wire right here. So normally on a standby, this would be done in your breaker panel, but since we're running this as a portable, we have to do it here to keep things safe. Now, this machine, it is rated at 20,000 watts. And testing it at that load is going to be a little bit of a challenge for a couple reasons. First off, the load bank, it's rated at 10,000 watts, so that'll get us halfway there. To supplement that, I'm going to use a few space heaters, 5 in total. So that'll be another 7,500 watts. And once you factor in the light and the wattage required by the cooling fans, we're going to be at about 90% load when everything's turned on. Now, we're not going to be able to do that for too long for a couple reasons. First off, my fuel supply, it's just 2 small grill propane tanks. I have 2 regulators on them that are good for 10,000 watts each. Those are connected with a T and feeding the machine. So like that, we should get 20,000 watts out of this setup. But due to the size of the tanks, the pressure is going to drop and we're not going to be able to hold it for too long. The other consideration is the wiring. I've got lots of breakout cords, which each connection adds resistance. And I'm only using 6-gauge wire, which can safely handle 12,000 watts continuously. And in this case, we're going to be going over that to 16,000 watts, and then the other 1,500 is going to come out of the convenience outlet. So yeah, we don't want to hold that kind of a load for too long for several different reasons. So let's get the engine started. While it's warming up, we'll double check the output using the kilowatt to measure the frequency in the hertz. We use the amp probe to see what total harmonic distortion is on this machine. And of this, I'm very curious because the last 2 Generac standbys I tested were very high at about 30% THD. This is a newer generation machine. And when I took the stator off, I noticed that the stator on these machines have a twist in the laminations. And that's usually associated with low THD. So I'd be surprised if we saw THD over 6%. But the amp probe will tell us that for sure. And we also have the oscilloscope so we can see what the output looks like. So let's get the engine started. We'll put it to the test and see what it can do. All right, no issues at all getting the machine started. And yeah, THD is quite low without a load, just around 2%. And the sine wave actually looks pretty clean. So yeah, not bad. Let's put on a 7,500 watt load with the space heaters. The engine hasn't even noticed. So we're now at 7,500 watts. THD remains pretty low at about 4%. Sine wave continues to look good. So let's give this a few minutes, then we'll bring it up to 12,000 watts. And if things continue to look good, we'll go for the max. Yeah, no issues at all. That's 7,500 watts. We're at exactly 120 volts, pretty much exactly 60 hertz. So let's increase the load. Right now we're at 7,500 watts, so if we put on another 25, we're now up to 10,000. Now 12,000 watts, so things continue to run well, and THD is virtually unchanged, 4.2%, and sine wave looks pretty good. And no issues at 12,000 watts. So let's go for more. Let's go for 14,000 watts, 16,000 watts, 17, and 17,500 watts. So that's the most I can do with this setup. We're at 4.2%, so that is really impressive. And the sine wave looks pretty good. So we'll give this a few minutes to make sure there's no surprises, but yeah, pretty impressive. All right, no issues at 90% load, so pretty impressive. Could handle that load. THD stayed below 5%. So a very big improvement from the older generation. All right, guys, and that is pretty much it. So this machine, I was hoping it was going to be a low THD machine, and it was. It actually exceeded my expectations. The last Generac standby I tested topped out at about 30% THD, and this one topped out at 4.2%. So that is very low, and not many traditional generators like this are low THD. Most of them are in the 20 to 30% range. So this is, I would say, one of the best I've tested, from that point of view. Anyway, this thing, it is 100%. I'm not sure yet where I'm going to go with that other engine that we pulled out of here, but we do have another standby to take a look at. That one does not make power, so maybe in a week or two we'll take a look at that, and with any luck, we'll get that one running as well. So, I hope this video helps someone. Thanks for watching.